Okay, so I know what some of you are thinking. You're thinking, is the test really going to ask me about Mike and Jen or Sam and Diane? Isn't the test really going to ask me harder work rate questions? Yep, it is. So why the heck did we just bother with the shortcut? Well, here's why. The shortcut is incredibly flexible, and because it's flexible, it can be used to handle really hard questions really fast. So, for example, let's say you don't have 2 people cleaning the garage. Let's say you've got 3 people cleaning the garage. What do you think you would do to the shortcut? Yeah, we're just going to add one more fraction. You got 4 people cleaning the garage, you're going to have 4 fractions. Now let's say we're not cleaning 1 garage. Let's say we're cleaning 4 garages. What do you think you would do to the shortcut then? Yeah, we're just going to set that whole equation equal to 4. If you're cleaning 1/4 of a garage, no problem. You set it equal to 1/4. You always set it equal to the amount of work you're doing. And because we can be so flexible in how we set up the shortcut, it can be used to handle really hard questions really easily and really fast. Let's take a look. Okay, let's up the difficulty. 2 painters are hired to paint a house. The first painter can paint the house in 6 hours, and the second painter can paint the house in 4 hours. How long will it take them working together to paint 2/3 of the house? All right, what are we being asked for? We need the time together to paint 2/3 of the house. What are we given? Well, the first painter paints the house in 6 hours, second painter paints the house in 4 hours, so we have each individual's time. And my guess is that mere moments ago, this would have seemed like a pretty difficult question. But with the brilliance of the shortcut, we can do this question in like no time flat, because we will take our 2 fractions, we will add them together, and they will equal not 1, but 2/3, because that is how much of the house we are painting. So we know that x is on the numerator because we're asked for time together. We know that 6 and 4 are in the denominators because those are the individual times. And we also know that all we do is multiply through by the common denominator of 12. And in no time flat, we are figuring out 2x plus 3x equals 8, 5x equals 8, x must be 8/5. Done. Excellent. Let's try another one. 2 painters are hired to paint a house. The first painter can paint the house in 6 hours, and the second painter can paint the house in 4 hours. On the first day, painter 1 painted by himself for 2 hours. How long did it take both painters working together to finish the house? Okay, what are we being asked for? We need the time together to finish the house. Okay, we'll talk about that in a second. That's important. All right, well, what are we given? Well, first painter can paint the house in 6 hours, and the second painter can paint the house in 4 hours. This is seeming very familiar to me. Painter 1 is 6, painter 2 is 4. We set up our equation. We have 2 fractions set equal to what exactly? Well, we have been asked time together to finish. Turns out that the word finish has a very precise mathematical meaning when you translate it from English into math. Finish is the total minus what's been completed. So in this case, the total is 1 house. How much has been completed by the second day? Well, let's see what happened on that first day. That first day, painter 1 shows up all by himself, and he paints for 2 hours all by himself. How much of the house did he get done in those 2 hours? You know what? I think he got 1/3 of the house done in those 2 hours. You know why? Because he can paint the entire thing in 6 hours. He worked for 2 hours. That means he all by himself completed 1/3 of the house. So that means what's left must be 1 minus 1/3 or 2/3. So we set our fraction equal to 2/3. Now, this is very easy. The numerator is just going to be x because that is always time together. One of the denominators is 6. One of the denominators is 4. And oh my goodness, this is identical to the equation in the last question. The math is the same. The only difference between the last question and this question is that in this question, you were made to translate the word finish. And that actually makes this question quite a bit more difficult for others. But for you, now that you have both the shortcut and full knowledge of what finish means, Now this is pretty darn straightforward. We are just going to multiply through by 12 again, and when we do the math is going to be exactly the same. 2x plus 3x equals 8, 5x equals 8, and we are again left with x equals 8/5. Okay, very nice job. Let's try one more. Pumps A, B, and C can fill an empty tank or drain a full tank in 2, 3, and 6 hours respectively. If pumps A and B are used to drain dirty water from a half-full tank, while pump C is pumping clean water into the tank, in how many hours will the tank be empty? All right, what are we being asked? In how many hours will the tank be empty? Okay, get that, but what exactly are we looking for? Well, let's use the framework here, because the framework can really allow us to only solve for one of four things. We're either solving for pump A's time alone, pump B's time alone, pump C's time alone, or their time together. So what we have to ask ourselves is, which one of those are we being asked for? Well, it looks to me like all of the pumps are switched on. All of the pumps are working simultaneously. So we must be being asked time together to empty the tank. All right, what are we given here? Well, pumps A, B, and C can fill an empty tank or drain a full tank in 2, 3, and 6 hours respectively. We are given each pump's individual time. What's next? Rely on the framework. We have 3 things working, so we need 3 fractions. We know that for sure. Hey, we even know what's going to be in the denominator of each fraction, because we know each individual's time goes into the denominator, and we know the numerator too, because numerator is time together, and that is what we are being asked to find. All right, so what does all this equal? What are we going to set it equal to? How much work are we trying to get done? We are trying to drain a half-full tank. Not trying to drain a full tank, not trying to drain an eighth of a tank, not trying to drain 6 tanks. Drain a half-full tank. That's how much work we're trying to get done. So our equation must equal 1/2. Now there's this very strange business about A and B. They're being used to drain dirty water, while pump C is pumping clean water into the tank. So let's think about this for a sec. So A and B, all right, they're buddies. They're working together. They are getting this job done. C is not helping. In fact, C is not only just not helping, C is actively going in the opposite direction. So how do we capture that in math? Well, it must be that pumps A and B are working together so they get a plus sign, but pump C is working in the opposite direction, so it gets a minus sign. And just like that, with a little aid from the excellent shortcut framework, we were able to put together this pretty tricky equation. All right, now all that's left to do is multiply through by the common denominator, which is 6, do our fancy crossing off, and arrive at an equation. 3x plus 2x minus x equals 3, 4x equals 3, x must equal 3/4. Very well done. Take a quick step back. The test is oftentimes going to put you in very uncomfortable situations in which you don't know exactly what you're being asked. Do not freak out. The very first thing we need to do is get things out of English and into math. This framework helps you do precisely that. All right, let's try one more. 3 robotic assembly units, A, B, and C, produce flexible screens for a new generation of smartphones. The time it takes them to produce a screen individually is 6, 15, and 18 minutes respectively. Robot A works alone on assembly line 1. Robots B and C work together on assembly line 2. What is the ratio of time it takes assembly line 1 to make a screen compared to assembly line 2? If you need to pause the video and reread this, I wouldn't blame you. There's a lot of information. Okay, as always, we start, what the heck are we being asked for? We need the ratio of time it takes assembly line 1 to make a screen compared to assembly line 2. Ratio on the test is code for what? Make a fraction. The numerator of the fraction is the time it takes line 1. The denominator of the fraction is the time that it takes assembly line 2. Now we know something about assembly line 1 and assembly line 2. Assembly line 1 is just robot A, and assembly line 2 is robots B and C working together. So robot A's time over robot B and C's time together. In math, that must be 6, because that's how long it takes robot A to make a screen, over x over 15 plus x over 18 equals 1, because that equation reflects how long it takes robots B and C working together to make a screen. So now all we have to do is do the arithmetic. Let's take a look at the denominator first. X over 15 plus x over 18 equals 1. We know when we're adding fractions, we multiply through by the common denominator, which is, in this case, 90. It is a dead useful math fact to know that the common denominator between 15 and 18 is 90. It comes up from time to time, so just know it. Okay, so all we do now is close out the arithmetic, which is 6x plus 5x equals 90. That means 11x must equal 90, or x equals 90 or 11, but that is only the denominator. The full thing is 6 over 90 over 11, which is the same thing as 6 times 11 over 90. And we know when we multiply fractions, we look for opportunities to do fancy crossing off. And in this case, 6 goes into 90 15 times. So our answer is 11 over 15. All right, so again, the hard work is getting this stuff out of English. Words don't do us any good, and into math. The excellent shortcut framework is very, very, very useful in helping you do just that.